Hello, my name is Mudavat Lakshman. Welcome to my Tech Talk. We are exploring the backbone of modern communications today, network protocols from the subject computer networks. We often take the internet for granted, right? But without these sets of rules, global communication would be impossible. Today we will dissect what protocols are, how they fit into the OSI model, and specific roles of major protocols like TCP, IP, HTTP, and DNS. Okay, let's dive into the slides of my PPT. What is network protocol? So the definition we can say for the network protocol is a set of established rules that dictate how data is formatted, transmitted, and received between the network devices, right? So as its core, a protocol is a language. Just as humans use grammar to understand each other, computer use protocols to ensure that one sent by one computer is interpreted as one by the other, right? It defines the syntax, what the data looks like, the semantic, the data means, and the timing when the data be sent. Okay, so the key functions of the network protocols are the data format, okay, and the meaning of each section, and the speed matching and the sequencing. Okay, next we jump into the OSI models. So what is OSI models first? Okay, so the OSI models are like, to understand the protocols we must look at the OSI model. Protocol are hierarchical. High level protocols like HTTP sit at the top, like we know hypertext transfer protocol, right? And while low level protocols like Ethernet sit at the bottom. As data moves down these layers, each layer add its own protocol header that we call like encapsulation, right? And ensuring the data reaches the right destination. So the protocols we have are like 7 layers. Okay, we can say from like the physical layer, data layer, network layer, transport layer, application layer. Okay, so we can say that PDN like TSPA. So there is service layer is there. Okay, so there are a lot. So in physical layer, there is cables and signals will be there, and data link layer, how the data is transferring. So it is done by the Ethernet and the MAC, right? Model access control. And then IP, that internet protocols will be there, ICMP, TCP protocols, UDP protocols, like that is diagram protocol, right? And HTTP, DNS, all of this will be there. And next we here is a 7 layers, right? The OSI model 7 layer. There is a physical layer, data link layer, network layer, and the transport layer, session layer, presentation layer, application layer is there. So by addressing the internet protocol now, the role is logical addressing and routing, right? The IP, like internet protocols role is logical addressing and routing will be done by the internet protocol. So let's start with the internet protocol now, okay? Or we can also say it IP. Its a primary role is addressing and routing. It's like a postal service system. It's known as address, like address, right? But it doesn't care if a package gets wet or lost. It is a connectionless and offers best effort delivery. It doesn't guarantee packets arrive in order, which is why we need the other protocol to help it. Okay. So the function is fragmentation of packets if there are two loads for the network. So this is a function of the internet protocol. And the transmission control protocol, oftenly called as TCP protocol, that is a reliable manager, right? So as we know, since IP is unreliable, we need TCP to provide reliability. TCP establishes a connection using a three-way handshake before any data flows. It numbers every packet. Okay, if a packet goes missing, TCP notices a missing number and asks for a retransmission. So it also handles a congestion, slowing down to transmission if the network is busy, right? So the three-way handshake is like SYN acknowledgement, and there is acknowledgement, right? So it takes the acknowledgement, which also called as ACK. And so these are the features. The key features are like three-way handshake and flow control, error control, congestion control. These all are the key features of the transmission control protocol, that is we call as TCP. And next we dive into the user datagram protocol, oftenly called as UDP. So the role is fast, connectionless, unreliable delivery. So if TCP is so reliable, why do we need UDP? So this is the first question, right? So speed matters. UDP removes all the overhead of handshakes and error checking. It's a fire and forget. For live streaming or gaming, You don't want to stream to pause to retrieve a missing pixel from 10 seconds ago. You'd rather skip it and keep playing. So UDP fills this role for real-time applications. So this is UDP. I hope the characteristics are like unlike the TCP protocol, it doesn't have it doesn't have handshake, it doesn't have ordering, and it is low overheaded. That is small header, right? So next we see the here is a UDP protocols diagram. We can see like there is a request, there is a response, there is a request and there is a response. No handshakes and no error checking, no congestion control will be done in the UDP. Next TCP and TCP versus UDP comparison. So the TCP versus UDP comparison is like think of TCP as a registered mail service where you sign for the package. Think of UDP as a sending a postcard. You hope it arrives, but you don't track it. So in the engineering world, we choose TCP for the data integrity, like downloading a file, and UDP for time sensitivity, like a voice call. So you got it? What is TCP and UDP? So next we jump into the HTTP and HTTPS. As we know that S is a secure, and as we know what is HTTP, that is hypertext transfer protocol. So this is a protocol which is which lies between the sender and the client, or we can say the client and the browser or the server. Okay. And there are some request models like get, post, put, delete, and these are all the like REST APIs. We can say these are the APIs. Moving up to the application layer, we have HTTP and HTTPS. So this is how browser talks to server. HTTP defines methods like get and post. However, standard HTTP is a plain text. Anyone can read it. HTTPS is encrypted this traffic using SSL. That is like we know there is certificates, right? SSL, TLS, ensuring that even if hackers intercept the data, they cannot read your passwords or credit card info. So this is all about HTTP and HTTPS. Next we jump into the DNS, that is domain name service. Okay, humans are bad at remembering like numbers like 192.1, 168.1.1. These are the IP protocols, right? These are the numbers we got, right? We prefer names. DNS acts as an interpreter's phone book. When you type a URL, a DNS query is sent. It follows a hierarchy from root server to TLD servers to find the specific IP. It primarily uses UDP because we want to look up to happen instantly. So that is domain name system. This works as a phone number book, right? And next, email protocols. So the email protocols are we know ST, SMTP, POP, IMAP. So these are the email relies on trio of protocols. SMTP is a mail truck that pushes your email to server. To read your email, you use either POP or IMAP. POP downloads the email to your device and deletes it from the server. And IMAP is a modern. It keeps the email on the server, allowing you to read the same mail on your phone and laptop seamlessly. Next we jump into the routing protocols, that is BGP. Here there is a diagram how the email protocols works, right? How the POP3 downloads, and here there is no IMAP, but IMAP is a modern one, right? So fine. And next we have routing protocols, that is BGP and OSPF, right? So BGP we can call it as border gateway protocol, and there is a exterior gateway protocol, that is EGP we can say, right? And OSPF we also can say OSPF, that is open shortest path first. So here routers needs map to direct traffic. Inside a company we use OSPF, which calculates the mathematically shortest path between major networks like AT&T and Verizon. We use BGP, right? So BGP is more about policy and economics than just speed. It decides which network route is cheaper or more politically allowed. Next we jump into the FTP, that file transfer protocol. So before cloud storage we had FTP. It's a robust protocol for moving large files. A unique aspect of FTP is that it uses two separate channels, one for telling the server what to do and one for actually sending the data. So that is all FTP. So this separation allows out a band control, which is greater managing transfer. Okay. Next, address resolution protocols. So the address resolution protocols, that is ARP and RARP. So here switches and LAN cards don't understand IP addresses, right? Switches and LAN cards don't understand IP addresses. They understand MAC addresses. ARP bridges this gap. When a device wants to talk to an IP, it shouts an ARP request on the local network. The device with the IP replies with its hardware address. This is essential for locally delivery. So next we jump into the dynamic host configuration protocol, that is DHCP. So the role is automatically assigns IP addresses and network configuration to devices. So imagine if you had a manually configure and an IP addresses for every phone, laptop and printer in a college. That's where DHCP comes in. It automates this. It uses a 4-step process called DORA, that is discover, offer, request and acknowledge, to lease an IP address to a device dynamically. Next we have wireless protocols. Next we jump into the wireless protocols. The wireless protocols, we can't forget wireless, right? So the 802.11 standard defined how Wi-Fi works, how wireless fidelities works. Unlike wide Ethernet, which detects collisions, Wi-Fi tries to avoid them using CSMA or CA. The evolution from G to Wi-Fi 6 represents massive improvement in speed and, more importantly, the ability to handle many devices in a small area without crashing. So the future protocols will be IPv6 and QUIC, that is we call it as quick. Okay, protocols evolve. We are slowly moving to IPv6 to accommodate billions of new devices. The web is also moving to HTTP by tree, which uses the QUIC protocol over UDP. This makes the web significantly faster and more stable on unstable networks like mobile data. We also see lightweight protocols like MQTT emerging for the Internet of Things, that is IoT we call us, right? And next, in conclusion, the internet is a complex stack of protocols working in a harmony. IP finds the destination, TCP ensures the data arrives intact, HTTP renders the page, and DNS helps us find it. A computer science student understanding the role of each protocol helps us troubleshoot networks and build better applications. Okay, thank you.